everyone. My name is Arkiti Chadda. I am an applied scientist at Microsoft. More specifically, I work for Bing Maps. I get a lot of questions whether Bing actually has maps, and yes, it does. It's not a consumer-facing app, so it's very likely that a lot of you have not used it, but if you use, say, USPS or you use Costco, and you try to search for a Costco near you, they are using us in the back end, so sort of technically I do some work on an everyday basis. My background was actually biomedical engineering, and then I spent a couple of years doing research on the interface of neuroscience and robotics. And a part of my project was here at University of Washington in Seattle. And I met all of these cool software engineers, and I hear they're working with machine learning and AI. And I was like, wait, I work in robotics, and I do the exact same thing. And it looks like that they seem cooler because they work for tech companies and they make double the amount of money that I do. So I was like, okay, great, let me go back to school. So I went to Northeastern University here in Seattle, and I got a master's in computer science. And while I was studying, I got introduced to machine learning and NLP in specific, and then I ended up at Microsoft. For the last couple of years, I have been working in search and relevance. So like I said, I work for Bing Maps. And my team specifically does location understanding. For all of you here who are from the Seattle area, if you went and searched for, say, Bellevue, WA, you would be expecting Bellevue, Washington to be returned. But it turns out that there's a Bellevue in Western Australia that's also WA. So how does Bing know what to return, whether you're looking for Bellevue, Washington or Bellevue, Western Australia? And that's what my team does. Now, over the years, now that I've spent a couple of months working, years for that matter, working on this field of search and relevance, I have gotten really passionate about it, and I thought maybe it might be a good thing to discuss with other women in the field and see if any of you might get interested. So I want to start off by saying that this is a beginner level talk, so there might be things that you already know about what I'm going to talk about, but I just wanted to give an introduction to what search and relevance actually is, if any of you ever get interested to work more in the field. So let's take a moment to go over what we will be covering today. I'm going to start with the motivation of why I wanted to do this talk and how we actually use search every day. I'll talk about how search engines work briefly, but more specifically we'll be talking about the science behind search. So I'll touch briefly on ranking algorithms, the natural language processing that happens behind it, what is the state of the art today, and a quick primer on how we actually evaluate whether or not the ranking is good or not. And then finally, we'll quickly wrap it up. Let's get started. How we use search every day. Now I'm going to show you this icon, and I'm sure all of you know what this is. I work for a competing company, but that's okay because most of us use Google on an everyday basis. But if you're worried about your privacy, maybe you know what this is. Does anyone here know what this is? DuckDuckGo. Yeah, so it came up in the last couple of years because everyone's worried about too many ads on Google. So let's just go ahead and use DuckDuckGo. But the relevance is also pretty okay. I work for Bing, I have to put it in, but I'm also going to put a shameless plug that Bing actually does really well in the US now, so if you haven't gone ahead and given it a try, you might want to. I put Yahoo search in, even though I don't think anybody uses Yahoo search anymore. I think I'm dating myself standing here. But I think growing up, I only used Yahoo search. It was Yahoo Messenger, Yahoo News, Yahoo search, all of the way. But also, when we think about search, all of us think about these traditional search engines. But when I woke up this morning, I asked Alexa what the weather was going to be. And then I was getting ready and I wanted to play some music, and I'm in my Taylor Swift era because she's playing and I didn't get tickets, so I have a concert every morning in my bathroom because why not? So I searched for the playlist that I wanted to listen to, and then it played the song. And then when I had to come here, I used Google Maps, and I asked for it to bring me to the Expedia office, and then I said search for Expedia Seattle, and it brought me here. And then on a normal day I'd be going to work. Today I came here. But then if all of you, I'm guessing most of you are technical here, and if you're not using Stack Overflow search, you're doing something wrong. You should be using Stack Overflow. So the reason I wanted to mention all of this is that we sometimes forget search is such an integral part of our lives, that it's not just the regular search engines or Googling things that include search, it's all of these smaller things on an everyday basis that we use search for. Search engines, I like to call, they're like superheroes, mostly because this is what my search looks like on an everyday basis, sometimes multiple times a day. Google doesn't have any answers for me because whatever. But like on a very serious note, Google handles more searches than most of us can make decisions because all of us are very poor decision makers. But just on the terms of numbers, Google handles more than 3.5 billion search queries in a day. Bing handles 1.5 billion search queries in a day, so all of you need to go and help us reach that number. But with so much data, it can be a challenge to deliver relevant results. Like, how do you know that a result is good enough or not? And that's where we start studying about what search engines are and how they actually work, and that's the primer that I'm going to be talking about today. So search engines actually have a very complex architecture, but to break it down into the smallest form, there are three major things at the core of the architecture. The first one is the crawler. Everyone talks about crawlers, and I'm sure you've heard about that word. But it's essentially an automated program which goes on the internet, and what it does is that it finds any new pages, web pages that might have come up, or any pages that might have been updated. So say I went ahead and built a website for myself, that's a new web page that has come up. So the search engine is going to have a web crawler that's going to figure out, okay, there's a new page that came up, and now I need to understand what's there in it. There could also be pages that have been updated. So Wikipedia, for example, keeps getting constantly updated. So if I have a V0 of Wikipedia in the search engine's memory, we want the latest update that happened this morning. So web crawlers are going to do this continuously, every day, automatically. Now, they try to get the content, they try to get the links, they try to get what are the kind of people that are visiting all of these websites and store it. Now they store it in something known as the web index, and this is essentially just going to be used by the search engine that when someone is looking for a query and they have to return something, they're going to go back to their index and find the relevant results. And I'm going to keep using the word relevant, and I'm going to keep saying that they're going to extract some sort of results. But what exactly does relevant mean? And how does the search engine decide what is relevant and what is not? This is where the ranking algorithms come in. The minute somebody says machine learning and the minute someone says ranking, everyone's like, oh, I'm so interested, because everyone wants to know what the buzz is about AI and machine learning. And that's actually what's happening. But at the base, at the crux, at the core of all of these ranking algorithms, it's just an understanding of one, language, and second, math. So all of the calculus classes that you've taken over the last couple of years in high school, the ones that you skipped, and now you're going to feel bad why you skipped them, because that's exactly what ranking algorithms are. All of us scientists and all of us in the industry like to make things really fancy, and they all sound really cool, and we go ahead and publish papers, but at the core of it, they're just understanding of language and math. So today I'm going to talk about some of the ranking algorithms that have been important as we've been searching for the last couple of years, and how they've evolved. So early in the 1990s, what was happening was when you enter a search query into the search box, early search engines, like I said, I was using Yahoo at the time as well. Most of these search engines relied on basic keyword matching. So say you put something into the search box, something like pizzas near me, until and unless all the words pizzas near me existed in a website, they wouldn't be returned. If a website had all of those words, then it would be returned because they were relying just on full keyword matching. Move over to 1998, Google introduced PageRank, where it started looking into, is the website popular? How did it decide whether or not it's popular? Could be a number of things. Could be, whether people are going and clicking on that website. Are people visiting it a lot? Does it have a lot of links in the website? Move over to, like for a very long time, Google was dominating, and of course, that's why all of us are using Google. But eventually, there are other players that started coming into search, and Bing introduced an algorithm which it called Bing Rank, and then said, maybe it's not just whether or not a page is popular, but it's also other signals. For example, are there other people around the person who's trying to access this page, which think this page is popular? So it started using social signals and started using cues from the user to understand whether or not something might be relevant. Move over to 2012, Google came back with Knowledge Graph. So if you go and search for a movie on Google, and then it'll show the cast, and it'll show the plot, and it'll show the reviews, all of that is essentially coming from the Knowledge Graph. So it's the idea that you don't just want to return a relevant result, you also want to return as much information as possible about the result, and that's getting accessed from the Knowledge Graph. Eventually, they were like, okay, we're going to do it one up, and then they came up with Rank Brain. And what they did here was, okay, we have all of this information about the query, we have all of the relevant results that are possible, but we also want to get context. Now, like I said, I work for Bing Maps, so we work with a lot of location data. If somebody is searching for Paris, for example, if someone's searching for Paris Hilton, if I go ahead and just return Paris as a location, that's just really bad at my end, because the person is likely not searching for Paris, the place. And then if someone's searching for Hilton Paris, and I go ahead and return, Paris Hilton, that's also bad. So this is where context comes in. But, so then the company started figuring out that, it's not just that the users are looking for something and that's there in the query. There's also context behind it. It's possible that there is a previous search query that would determine what I could use. Maybe there's more information in the query itself. And that's where rank were in. And then finally, all of us have heard about BERT. Is there anyone here who hasn't heard about BERT? Thought as much. Okay, so BERT is essentially, it's a natural language processing algorithm that Google came up with. And what they said was that, okay, we were able to use all of these other signals and cues to figure out context. But what if I wanted to get context within the query itself? There is a city called Love in Italy. So if someone's searching for I love Italy, are they searching for the place Love in Italy? Or are they searching for, I love Italy, the t-shirts or whatever? So all of this, they were like, okay, can we use context in the query itself? And that's where they started using BERT. There is a talk on BERT here. I'm fairly sure I saw it on the page. So if you're more interested, maybe that talk will be interesting for you. Now I'm going to talk about all of these ranking algorithms. It might be better if I talk about it in terms of an example query. So say I went and searched for the best pizza in New York. So in the 1990s, what would have happened was any blog that said best pizzas in New York would have shown up, regardless of whether it actually talked about pizzas or not, just because of the fact that it said best pizzas in New York. If I had a blog which just said best pizzas in New York like 100 times, that would be searched, surfaced on the top, because that's how we did it. We had keyword matching, same keywords matched multiple number of times. This is the most relevant result we're going to return this. Then we moved over to Google's PageRank, and then it said, okay, let me be Yelp page about this particular pizza joint is getting a lot of clicks, and every time someone searches for best pizza in New York, they go and click this link. So maybe you should start returning that Yelp page. So that's what that did. We moved over to Bing Rank and Knowledge Graph. So what Bing Rank would do was, if say in my vicinity everyone was searching more for pizzas that sold pepperoni pizza, everyone around me would start getting those recommendations, and then we wouldn't get pizza spots that sold like mushroom pizza or like margarita pizza for that matter, because it would take all of the social cues. And then knowledge graph. This is a very funny example of knowledge graph, but like say there was a knowledge graph that was activated. What that would do was when I searched for best pizzas in New York, I'd get what is pizza, the history of pizza, pizza was made in Italy, what is the history of pizza in Italy, so all of the information about it. And then eventually around like context. So say somebody was searching for best pizzas places in New York for a family, or romantic date spots for pizzas in New York. So what's happening there is that, okay, you get the context, so now you don't want to search for all of the pizza spots, but only the ones that have romantic anthems in them. Now, we talked about BERT a little bit, so we're going to quickly talk about, what are the different other natural language processes that are happening in that area. The one that is most common, that most people are able to see, are actually autocomplete. So whenever you're trying to search for a query, you start typing something in the search bar, you'll be able to see that there's some sort of auto-suggest or auto-completion that is happening. As you see, the one on the right is Bing, the one on the left is Google. Both of them are different results, not just because they're different websites, their algorithms are different, but also because my search history is probably different in both of those search engines. Now, it's not just autocomplete. I think that's something that we very commonly see, but there are other important things that happen in the language. And this is what I meant, that when there are ranking algorithms, there are other, it's mostly just language and math. So how do you take this language and perform math on it? And these are the two most common things that happen. One is NER tagging. So for example, for a query, what is the capital of France? The search engine is now going to figure out that France is actually a proper noun, it's the name of a country. And then the query also has what and capital. So when the results are getting ranked, it's going to start giving me either Paris, that's going to be a good result, or it's going to give me a list of capitals of different countries, that's going to be a good result. Now the other things that I've mentioned here, not fairly important in the context of search, but search is very close to recommendations. So sentiment analysis for Twitter, for example, your feed will look very different from your friend's feed, because the way that you're interacting with that feed is going to be very different. So sentiment analysis, entity linking, context, and intent understanding is something that we've already talked about. Now the state of the art. There's two pictures here. One of them is a Google search on the left, and the other one is ChatGPT. Is there anybody who hasn't used ChatGPT in this room? Great. And the reason I wanted to bring it up is how ChatGPT, or like the new language models, are now changing the face of search. I could do a complex search query. In this case, what I'm searching for is what are some of the good books to read if I enjoy The Catcher in the Rye and why. Google is able to give me like a list of books that I should read. but it's not going to be able to tell me why. However, if you see ChatGPT's response, it's actually able to tell me that these are the 5 books, and you should read the first book for this reason, the second for this reason. It's highly personalized. And the importance of ChatGPT is not just that it's able to do search, but also that it's able to give me the response in a more human-like language that's easy for me to understand, easy for me to interpret, and something that I, as a layman, am going to interact with more. So again, ChatGPT language models are now changing the face of search. And we sort of have come a long way when it comes to, doing keyword matching to going into large language models like GPTs. However, of course, there are limitations of, there's a lot of time that is required for training, and there are probably biases. But I think we're all going in the right direction to see how search can actually improve. Now, I talked about search for a very long time, and I talked about relevance, and I said that we're going to be using that word a lot. But how do we decide what is good relevance? And I'm going to drop some of these here because I'm running out of time. So what I'm going to do is I'm going to mention some of these metrics here. And what all of these are, the first 3 will be available to anyone who's been working in data science. So precision, mean average precision, normalized discounted cumulative gain. These are very quantitative metrics that we use to see whether or not a search that has been returned is good or not. Mostly in information retrieval, we'll use the third one, which is NDCG, which says, okay, a search result is good, but it is good enough only if it's the first result that I get. Does anyone ever go to the second page of Google? I don't think so. So if the relevant result, a good result in the second page, no one really cares. There are other metrics that we're able to see, for example, dwell time and click-through rate, and as the name suggests, how much time I'm spending on the website, whether or not I'm clicking on a website. Those are also metrics that the search engines can use. Now, I'm quickly going to wrap it up, and I want to say that, I started off this talk by saying that search is such an integral part of our lives. And if you are in data science and if you're interested more in how this works, I hope that this talk was able to motivate you to look into a little bit more about how the search actually is happening. It's not that difficult. It comes off as it's like a big bear, especially when everyone starts talking about the billions of parameters that ChatGPT is using. But once you start getting into it, it's a very beautiful story of how things actually work. I really like this because it says Google can do everything, but it can't figure out whether or not you're a robot. So I'm like, okay, I wish that the future that we're heading to, we don't have to justify that whether or not I'm a robot. So from simple keyword matching models to advanced models like GPT-3, it's clear that we've come a very long way. But as with anything, there's always room for improvement. There's lots of biases that are happening in the search right now. Ads, of course, are something that are tracking. Everything that we do and the search results that we have are more often than not targeted by ads and are based on whether or not companies paying them to show the results. So I'm hoping that we can move past all of this, but I'm really excited to be able to share all of this information with you and hoping that we can have a little more chat. So if you have any questions for me, I'm happy to answer them, and I'm hoping that you'll be able to spend more time trying to understand what search and relevance actually is and how Inference works. Thank you.
Thank you for the talk, Arkiti. We'll open it up for questions. All right.
Hi, Arkiti. My name is Sonali. So one thing that we notice is that on internet nowadays, there's a lot of repetitive information, right? So how does can this complicate the searching process or the ranking process?
Definitely. When there is, so SEO is something that people are trying to use. So for the same product, for example, a moisturizer that's out there, what companies are now trying to do is so that they can come up in the search results, they write website, they write blogs about a moisturizer. More often than not, if you go to 2 different websites and read the blog, it will have the same content. So that problem is definitely there. However, we've reached a scale in commercial machine learning that's probably not going to cause an issue because they, like I said, it's not just regular keyword matching, so they don't just care about the content, they're also going to care about the clicks, for example, or what other information is there on the website. Are there other websites that point to that website or not? So there's a bunch of different features which are now available. So in the grander scheme of things, not really, but if you were to say start a project and start working on crawling the internet to figure out data for yourself, then it might be problems.
Thank you.
Hi, thank you for your talk. Say that someone finds themselves in a position where they don't know much about search, but they have been tasked with improving relevancy on a very basic search. What are some sort of resources or methods that they could use to just make whatever the search that they are now in charge of better, that doesn't necessarily involve like large machine learning algorithms or ChatGPT?
It definitely doesn't need to involve like large machine learning models and ChatGPT. And we were having this discussion in one of the breakout rooms this morning that everyone who's in school and who's doing research thinks we have to keep getting better incrementally in terms of like the performance. But when you work in the industry, you quickly realize that's not what happens. We start from like the simplest of models. I've put a bunch of resources here. The Google AI blog and the Microsoft research blogs are actually really good places to start because both of them have information about the basic search, how it works, and how they're doing search. There's also a bunch of textbooks that I'd use on an everyday basis. But for someone, in a particular domain, if you were trying to make search better, I would try to understand what kind of data you have and what are the results that you're actually expecting. And then, just the way a machine learning model works, I would figure out what are the different features that would impact it. I guess the simplest model I would start with is random forests and see where it goes from there. But I guess you also have to answer the question of, do you care about only the top result? Do you care about the top 5 results? Do you care about the top 10 results? So for example, for maps, I only care about the first result because if I show you 2 different values, it's not really going to make a difference. But for Google, they care about the top 10 or the first 10 things that you see on the first page. So once you start building your answer in that sense, you might be able to use some of the resources listed here to help you with the process.
Thanks so much for your presentation. My question overlaps a little. If someone's interested in search but not familiar with a lot of the advanced models, in your opinion, how realistic is it to get an opportunity in the industry for a beginner in search? It just seems like such a knowledge gap to get to the most advanced.
Absolutely, and that's the thing that I said when I was ending my talk. This is the reason that I wanted to give this talk, because it can be so overwhelming that there's so much stuff happening. You actually don't need to know everything about the language models. Now the language models are generative text, so it's trying to make it more human as possible in the responses that it's giving to you. But the basic search doesn't need all of that. What it's going to do is going to take the information that is already available on the internet and then return it to you in a way, in a list that's going to be relevant to you. You do not need to know the large language models. You don't even need to know a lot of deep learning. It gets better, yes. But say you were working for a smaller company and doing internal search for them, there's not going to be enough data for you to be even using deep learning. So basic machine learning algorithms are going to be more than enough for you to do information retrieval and search for them. So I'd say that if you haven't started already, I'd go and start reading about information retrieval. There's a book that I mentioned here. It's the classic book in information retrieval. You can build like a basic search engine just by like the 5th chapter, and that should be good enough to get you started in the industry.
Which book is that?
Introduction to Information Retrieval.
Okay. We'll take the last question.
Hi, thank you for your talk. So one question I have is that a lot of times you give context to the search engines and a lot of context, and what happens is that it ends up giving irrelevant results. Is there a way to handle that, or is it something to do with the data that we use to build these algorithms?
That's a good question. I think most of the regular search engines, this includes like Google, Bing, Yahoo. If you were going to a search box and trying to search for something, they are not very equipped for longer queries. So it's not necessarily the context that is the problem, it is the query that itself and the size of the query that is the problem. So I'd suggest that if you wanted to give more context, now we have access to ChatGPT. It does really well. The more context you give it, the better the responses get. So you might be able to work your way around it. But for regular search engines, just keep your query as short as possible. It might be able to use context within that short query itself, but there's not much we can do at this point. Yeah.
Thank you.
What a great presentation, really.
All right,
Thank you so
thanks
much,
everyone.
everyone.